Now I would like to discuss about the polynomial representation in data structure. Polynomial in data structure. That means what is a here I would like to discuss what is a polynomial, how we are representing the polynomials by using arrays, and then polynomial ADT. I simply write the polynomial abstract data type. So, first of all, I would like to start what is a polynomial. We know that the polynomial is a sum of terms. Sum of terms. Here, each term is in the form of a x to the power of e. So, this is the one term. Suppose we are going to be adding or subtracting such a terms, it will be form the polynomial. Here we can understand x is a variable. That means the value of the x may be changed, and a is known as a coefficient. A is known as a coefficient, and e is known as the exponent. E is known as the exponent. And here we can observe one more thing is the coefficient value, the a value, coefficient means the a value, and e value may be positive or negative. The sign of the a value and coefficient value and exponent value may be positive and negative. And a, especially the coefficient may be a integer or float or any value. But the exponent e must be an integer, must be an integer or an whole number. Here I write integer. That means we can write 3x square, or we can write example minus 4x to the power of 4x cube, or we can write minus 2.5 x to the power of 5. But it is not right. We are unable to write as, for example, 3 point, 3x to the power of 5.2. So this is not defined actually, but so this is wrong. But minus 4x to the power of minus 4, this also be right. So here the coefficient may be a positive or negative or integer or a floating point, but the exponent must be an integer. For example, the following are the examples for the polynomial, right? I am going to be consider one of the polynomial is ax, right? I am going to be write it as 3x to the power of 20 plus 2x to the power of 5 plus 15. So this is one of the polynomial. I am going to be consider another polynomial bx equal to x to the power of 4 plus 10x cube plus 3x square plus 1, right? These are the examples of the polynomial. Here we consider in any polynomial the highest exponent value, right? Suppose in ax the highest exponent value is 20, that is the e equal to 20. In second polynomial bx the highest exponent value is 4. So these are the exponent values. Exponent values. The highest exponent value in any polynomial, we are going to call it as a degree. So the degree means highest exponent values. We can also represent the polynomials mathematically as, that means I write here mathematical or representation. Mathematical representation of the polynomial. representation of polynomial is, suppose I am right, I am going to consider the first polynomial ax. Ax I am going to remember sigma ai x to the power of I. Similarly, I am going to consider the second polynomial bx also be the same sigma bi x to the power of I. So generally, we represent the polynomials in the descending order of their exponents. So here also we observe that we are going to be consider actually. So here the descending order first x to the power of 4 is there, the exponent value, next x cube, next x square. Here also x to the power of 20, x to the power of 5 and x to the power of 0 constant means. So we can represent the polynomials as the descending order of their degrees. And how we are going to be represent the polynomials. To represent the polynomials, there are two possible ways. One, we are using the arrays. Generally, we are going to be representing the polynomials in arrays. This is also sometimes called as the global representation of the polynomials. Global representation of the polynomials. The second one, we represent the polynomials by using the linked lists. So, first I would like to represent the polynomials by using the arrays. To represent the polynomials, the structure of the array is like that. Suppose we know that the array is a linear data structure where the elements are stored in a consecutive memory locations. So here I am going to be consider the array is like that. Don't worry, don't be confusing. Here I am going to be consider the two-dimensional array, and this is the zero location. The zero location consider the two parts, and this is the first location, and this is the second location, and so on. This is the third location, and so on. This is the nth location, like that. Here, in the first part of the location, I am going to be store coefficient. I am going to call it as COEF, and in the second part, I am going to be store the exponent because the polynomial term is in the form of a x to the power of e, right? So to store, for example, I am going to be consider 3x to the power of 4 plus 2x cube plus 5x square plus 9. Suppose let us consider, so this is the polynomial. Then how I am going to store is first the 3 in the zero term and its exponent 4 here and 2 here and its exponent second term 3 is here, right? And for the third term the coefficient value 5 is here and 2 exponent 2 is here and 9 is here. There is no exponent. The no exponent means x to the power of 0. The 0 is here. In this way, I am going to be store the polynomial using arrays. To store the polynomials in the array, I am going to be represent a data structure. Please observe carefully. So I am take the one data structure. I define number of terms. So for that reason, I am going to be write hash define define max term or max size or maximum terms because terms is number of terms in the polynomial equal to 100. That means this array can store the 100 terms of a polynomial. So I am going to be consider This is the large array. This large array can store the 100 terms of the polynomial. Suppose this is the 0th term and then this is the 99th term. Actually, the total number of terms in an array. Here, I am going to use as define because we know that to define the constants either in C or C++, we are using the hash define. Next, I would like to create my own data structure by using the type definition. I am right, type def. So the type definition is also used in C or C++ to create user defined data types. Type definition, I write structure. That means the term is how the term is the structure. So the we know that ax to the power of e, this is known as the coefficient. The coefficient may be the integer or float. Here I am going to consider float, coef, and integer. The exponent is an integer, so int exp, right? So this is the structure of this one. Actually, this is the structure of this array. This is the coefficient, this is the exponent, and I name this one as a poly. So with the name of the poly, one array of 100 terms is created, right? This is the user defined data type. Now I would like to explain how we are going to be declare this one. So uh, friends, please observe carefully. So now my data structure, I am going to be create my own data type. My own data type name is poly. Now I declare poly terms of max underscore terms, right? And I write one more variable, int avail, available location, equal to 0. So what happened here means the terms, suppose the name of the array is terms, the name of the array is terms. So this array name is terms. It is a poly type. So it is a poly type. Poly has the two things. One is the coefficient, another one is the exponent. This is the 0 term and its maximum terms equal to 100. This is the 99 term, and available location always points to the starting location, that is avail equal to 0. Okay friends, now I would like to store one of the uh, any one of the polynomial in this. So I am going to be consider one of the polynomial a to the power of x equal to 2x to the power of 50 plus 1, and one more polynomial bx equal to x to the power of 4 plus 10x cube plus 3x square plus 1. How I am going to be store these two polynomials in my terms array, right, which is of the poly type. Okay, here I am going to be represent this one. This is an array. This is the multi-dimensional array because each location is again subdivided into the two locations. This name is terms and is the type of poly, like int a. A is a variable of integer type. In the above I represent. So I'm going to write that polyterms. The terms is the array of polytype. So this is the coefficient. This is the coefficient I am already discussing. This is the exponent. The first one is stored. This is the 2 and this is the 50. In second location of the coefficient, this is the 1 and this is the 0. So this is the start of the first polynomial. This is the finish or end of end of first polynomial, and this is the second term, this is the third term, and this is the fourth term, and this is the fifth term, and so on. This is the sixth term, and so on. From here onwards, without wasting of the memory, I start to store the b polynomial. Now the coefficient is 1 and exponent is 4 and coefficient is 10 and exponent is 3 and coefficient is 3, exponent is 2 and coefficient is 1 and exponent is 0. This is the actually end of b polynomial. So the next location is 0, so available memory, so avail equal to this one. Okay friends, I hope you can understand how to represent the polynomials. Okay, thank you.